on pellets and chips in community housing and the service sector. My name is Eric VIAL from the Propellet Association. Propellet is an association for heating based on pellets across France. So we bring together different professionals, producers, distributors, people who actually make devices, manufacturers, distributors, installers, and we have to run the sector. We have to allow for observations, we look at prices, numbers of installations, we have to improve quality. So we promote different quality systems for the pellet sector, and we have to train and communicate people. So I'll hand over to my partner, Stéphane, who was part of the study. He represents CIBE, and he will present the study. Thank you, Eric. So Stéphane COUSIN from the CIBE. The CIBE is the Interprofessional Committee for Firewood, and it brings together stakeholders in community heating, industrial heating based on wood. So there are over 150 companies. The objective is to professionalize the wood sector and train people as well and promote heating systems. So community heating systems. For its work, there are 4 different commissions. So we've got supply people, people involved in more technological aspects, then people involved in legal and financial aspects, and tax aspects too. Tax questions are taken into account with respect to installations, with respect to projects, and there are other people involved. I'm sorry, the sound is not very good because the gentleman is not wearing a headset with microphone. So the presentation has 3 parts, 2 main parts. So we'll start with a quick introduction. We'll talk about the studies. And then we'll look at the situation of the pellet sector in France. And we'll look at the difference between pellets and chips. So we decided to present pellets as part of this presentation rather than the chips themselves, because we consider that this is a fairly habitual kind of fuel. So people are familiar with this, people who are involved in community heating. Pellets are very specific, so we're going to focus on that. So we're going to look at the use between pellets and chips for biomass heating systems. So by way of introduction, the idea is to better understand and better help people, because what we're seeing in heating systems and industrial heating systems included, there are those that are based on chips, those that are based on pellets. I'm sorry, the sound is really not very good. So there are many different systems. 20% of community heating systems, for example, use this kind of fuel.
Donc en fait, on les connaissait pas forcément très bien.
So we're not very familiar with these heating systems, district heating systems. So a study was carried out. It was launched by ADEME, and it was carried out by Propellet and SNPC. The objective is to look at the situation in terms of production in France, but also to identify community industrial service sector installations and understand the logic behind them, and then to carry out some simulations, see where there is any kind of disturbance when it comes to pellet-based or chip-based systems. So I'll take over for the pellets. Let's have a look at the situation in France. So I can't move the slide, Stéphane. So you double click, or I can maybe change the slides for you. So I'm clicking and it's not working. So I will take over control. So very quickly, when it comes to production, you've got the map that shows us different production sites in France. The production is very much shared out with about 60 industrial sites. In 2019, we had 1.6 million tons in terms of production. This year, it's more like 1.8 million. So that in 2020, I mean. We've got different sizes, but mostly 90% have over 10,000 tons worth. So it's a sector that has been developing quickly over the past 10 years. And we're looking at over 100,000 tons a year. So in terms of production and consumption, what's interesting to note here, in red on the graph, you've got the production, and in blue, you've got consumption. So the production and consumption are very similar. So some years one is greater than the other, but we're really very much self-sufficient in France. There is an adjustment variable that can be added to this, and that is import and export, because producers can't store everything that they produce over the year. They can't consume it straight away. So they also want to export. So they export all year long, especially to our Italians who consume twice as many pellets as we do. So they use pellets all year long. So the import is offset by the export, and the export is can be a bit lower and vice versa. So as it says, we're looking at imports from Belgium, Spain, very rarely from the north of Europe. And I've talked about exports already. So we can move on to the next slide, please. So where does the raw material come from for pellets? Well, we've got to be very clear about this. So 90-95% of the raw materials come from sawmills, so sawdust, shavings, shreds. So we're talking about softwood, because sawmills work mainly with softwood today. And this raw material that's used, that comes from sawmills, well, it's been going up for a while now. Some industries used to use a lot, so industries using panels, but there are also paper mills that are lowering their activity, that are closing as well. So that means that there are fewer raw materials from these sectors. So this means that we need other sources. And then when it comes to wooden constructions, there are also related products there that are concerned. So 50% of what goes into a sawmill comes out as a related product. It's not construction wood as such. So it's not really waste. So there's a resource that's increasing, that is related, and that is from logs. So this is a raw material that can be used for chips, because wood chips are based on this. So this again is another opportunity for pellets. And then there is hardwood that can be used to make pellets. It only accounts for 5% of the market today. So what about the characteristics of wood pellets? Well, we've got a table here that shows us the different characteristics of pellets, and I'll focus on two. As I said, they stem from each other. There's the rate of humidity. So this characterizes pellets. So with respect to logs, so we're looking at 25% less humidity. So the heat value you can see the heat value of 4,600 is high, and that's what is the advantage of a pellet. What we've got to realize is that there are three main aspects. So there are pellets for community heating, there are pellets for large community heating systems, and pellets for industrial heating systems. And we'll see that in France, it's category 1 that dominates, because we use only premium quality for various reasons. But the first is that these factories, well, it's very difficult to have different types of products. So just like for distributors, it's a fairly recent form of energy, so we don't have enough volume yet to justify having more stock of different products, that is. So the industrial quality is I1, I2, so it's not used, or very little used in France. It's mainly used, in fact, in Paris by the urban heating company that consumes several thousand tons of that product, but that's the only place where that kind of characteristic is used, and it's imported. Now, as I was saying, we're talking about softwood pellets mainly. So from sawmills, the raw material comes from sawmills, and sawmills work with softwood, but there is hardwood as well that is used. So we're not talking about big volumes. It's perhaps one factory that produces 6% of the volume based on softwood, but it's mixed with softwood as well. There are very few that just work on hardwoods, but we're talking about very small factories. And then you've got certified pellets as well, because you have to prove quality to customers. And the standard gives a quality reference. So there's a guarantee that the producer produces according to the standard. So we've got different standards: NF biocombustible or biofuels, solid biofuels, DIN plus and EN plus. Some producers are not certified, but they're small producers. They don't necessarily have to be certified, and they produce quality that might be good, but may not be good either. So that's something that could be improved in the future. What about the opportunities for pellets? Well, for domestic, we're talking about 95% of the market. This is what Stéphane was saying. We've got a big volume on the domestic, in terms of domestic use, and there's a huge growth of sales in equipment for pellets. So we're looking at different devices, so furnaces, stoves. So we've got them shown in the graph there in blue and in orange. So independent devices in blue and furnaces in orange. That's because there is help for people to move away from fuel. So you can see that the figures were stable in 2020. This year, the figures are going up. You can see that there are more stoves today in terms of number of devices, in terms of volume of energy as well. The volume of energy is very high. And this is what we can see on the graph as well. I think, okay. So opportunities, of course, there are opportunities in the community heating and industrial sector. So we're looking at over 50 kilowatts in terms of production of energy. So pellets, and this is what the studies showed, most of pellet applications in the service sector and the industrial sector concern small powers, less than 300 kilowatts, because of the flexibility, but also because of the cost. It's a little bit higher than for chips. So the more energy is consumed, the less competitive is the pellet. So I won't go back over what Stéphane said, but you can see the consumption is fairly low, 1.8 million tons in 2019. And you can see that we've only got a small amount for the community heating and service sector. So I'll hand back over to Stéphane now. Thank you, Eric. So as you've just seen, wood pellets have different opportunities in community heating systems and industrial heating systems. I've given you the percentage. So for the industrial sector, we're looking at just 2% of energy from furnaces. There are different reasons for this. There were gaps in knowledge and the logic that was applied as well. In terms of pellets, we actually studied all of these different aspects. So now I'm going to present to you the main results of the study. So let's have a look at the logic underlying these different types of furnaces. So there are two slides that concern district heating systems. So very often project owners want pellets to be used, or they want chips to be used. They want wood to be used, basically. Now, there might be a wish for local wood from the municipality. So, or wood from chips from forests or hedgerows. So then we have managers in the sector and design office engineers who study the best kind of situation, best kind of solution. As Eric was saying, there's the question of power that has to be taken into account. Above a certain power level, pellets are too expensive for the heat generators. So then we turn to chips. Chips often generate too high an investment cost, so often pellets are used. But there's an intermediate power range that depends on a number of things. Both solutions, chips and pellets, can be used in this case. So firewood, whatever the pellet or chip used, it can be compared to fossil fuel most of the time. So natural gas, domestic fuel, propane. And what we are seeing is that in sectors using natural gas, is that the competitiveness of wood is difficult to guarantee. So that's why there aren't very many furnaces using pellets or chips compared with natural gas. So faced with domestic fuel or propane, pellet and chip installations are nevertheless competitive. So that's why we don't really have natural gas. Now the comparison so there are two things that need to be looked at here because they will tell us what choice has to be made in terms of pellets and chips. The first criterion is the surface area of the site for the furnace. So a chip furnace, it's like a silo that requires a certain volume. So the pellet furnace is like a furnace, but the density of pellets is higher than that of chips. So for the same quantity of energy used, there's less need for storage. So you need less volume and surface area. If there's not enough surface area, then the chips will not be able to be used because the silo will not be able to be integrated. So pellets, you've also got accessibility to the site to trucks, because most of the time chips have to be taken right up to the silo, so the truck has to be able to enter. If the truck can't enter, can't go right up to the silo, then it becomes very difficult. So it's better probably to think about a different solution, an offset solution. And this is normally a solution that might be based on pellets, because they can be delivered in a different manner. There are two other criteria that might guide the choice as well. They're not as drastic as the others. There are technical and financial questions for operating the system that have to be taken account. It's easier to operate pellet-based systems rather than chip-based systems. So the personnel, the staff, find it easier, and have the skills usually to operate a pellet-based system, whereas it's more difficult for chips. And that means you have to bring in professional operators. So the professionals can, of course, operate the chip-based systems. There's also an analysis that has to be carried out in terms of the investment operating costs. That's something that can guide a choice. There are different rules because chip systems require a bigger investment, so they're more costly in terms of investment, but less costly to run. So the deciding factor is often the economic analysis, and in terms of global cost that covers all of the heat costs, the produced heat cost, whether we're talking about fuel, whether we're talking about operation or maintenance, supplies and maintenance, and the financing of the installation, you know, taking into account any financial aid that may have been allowed. So you've got a graph on the right that shows us the breakdown of the overall cost of heat produced. You've got fossil energy. So you've got 85% that is in fossil fuel. Then you've got the wood chips. You see the breakdown for wood chips. So 16% in terms of fossil fuel. And for pellets, it's 61% in terms of wood fuel. Now, the financing cost and operating costs are also very important compared with fossil fuels. So the pellet solution is an intermediate between the two, in fact. So you can see this reflects what I was saying with respect to investment and operating costs. There's more investment cost than there is operating cost. So to depreciate this investment, you need more energy. So the chips would be less costly in this case. And if you need little energy, so you can have a more costly fuel. And that's when you would choose a pellet-based system. So the point in common between pellets and chips is the intermittent aspect. Intermittent aspect, what do we mean by intermittence? Well, it's the taking into account of variations over the course of the different seasons, not the variations over the course of the same day, because you can have a water storage boiler to compensate for that. You have to look at the week or the season or the year. If you take community housing, you have to heat it every week, every day, with different temperatures during the day compared with the evening. But if it's a school, you don't need to heat the school to the same level at the weekend or during the school holidays or during the night. It's this notion of intermittence that has to be taken into consideration. And so for the same installed power in a furnace, in community housing or in a school, you don't have the same quantity of energy produced every year. So the higher the quantity of energy produced, so the better it is to use fuel with the lowest cost. So that's the kind of comparison that you have to make. So for service sector buildings or school buildings, the power that allows you to use pellets is going to be higher because the consumption of fuel associated with a given power is going to be smaller. So this notion of intermittence, you need to look at it by dividing the quantity of energy, the quantity of heat produced on a yearly basis by the power of the furnace itself. And you can realize that most installations, we're looking at lower than 150, well, some can 150 to 200 kilowatts. So it really is the range, the biggest range. You can have specific installation cases with higher powers, but those are fairly marginal. But as I was saying, that there's you have to take into account the use in order to decide whether to use a pellet-based system or a chip-based system. So if it's service sector or a school building or community housing. So the study allowed us to draw up this organization chart, this flow chart, that shows us a certain number of criteria and parameters. It tells us whether pellets or chips are the best. This doesn't mean to say that you haven't to carry out an analysis or a more in-depth study, depending on the project-specific characteristics. So number of housing units to be heated, for example, if it's community housing, but also climate aspects need to be taken into account, the kind of insulation used in the building. So you have to take other aspects into account as well. So you can fraction the power across different heating systems, different furnaces. This is something that's fairly commonplace. So a pellet furnace operates at 10 to 15% of its nominal power and produces good yield. For chip systems, it's 25 to 30%. It will depend on the manufacturer. We're looking at 25% mainly on average. So pellet systems have an advantage over chip systems. You can modulate more than compared with a heating system with the same power. So as I've said, you've got to take the power into account. So you've got longer energy times for the use of pellets. So the fuel is homogeneous. There are fewer concerns, fewer problems, fewer feeding problems, fewer supply problems, whereas with chips, sometimes they get caught in the feeding system. So these mean that you don't have to use too much fossil fuels. However, you can go up to 100% of heat provided by pellets, but then you've got to look at the total power required for very cold days. So you need to make the right investment. That investment can be quite substantial just for the 10% of energy that's missing.
So the study also enabled us to perform a certain number of simulation exercises. Just a few words on that. These were carried out in terms of the global cost. So for the three different types of energies, fossil fuel, pellets and wood chips, the aim being to work out how competitive wood was. And in terms of the competitiveness, we wanted to compare the competitiveness of pellets and wood chips. So 4 separate situations were put in place. First of all, the intermittence of use, in other words, the number of hours during which the boiler or the furnace functioned 100%. Then also the different situations that I referred to earlier, plus the possibility or not to get the equipment reimbursed. So in fact, the residential sector, the teaching sector, the tertiary sector, and the association sector were all taken into account. They have a certain number of full power hours during which they require heating. And so we believe that the results should be that it would be easier, it would be more profitable, better to use pellets than wood chips, for at least for virtually all of these sectors. The health sector, for example, nevertheless, we imagined potentially might have greater needs, so wood chips might be better. And what we saw in the field was exactly what we expected to see. However, we were able to see a certain amount of information as to where we should use pellets and where we should use wood chips. And so it did comfort us in what we thought, which was that you have to have a case-by-case approach and not base your approach on ratios that you presume over before you actually go to the site. So here you've got an illustration, thanks to the graph, of the simulations that we implemented, and you can find these in the studies. This is for collective housing. At the top, you've got the graphs that are quite intuitive in that clearly there are needs, for example, increasing needs for the heating as the day goes by, and then you've got the cost of the heat. And so you can see that the 3 colors concern the different types of fuel, and the dark brown is the wood chips, and then the light color, the pellets. So we can see that there are some times when the curves meet each other, and on the right hand side you've got domestic fuel, and here you can see the competitiveness that is a lot more difficult to achieve, particularly within the scope of natural gas, because the wood chips and the pellets are naturally below the cost of the fuel. The graph below is maybe slightly less intuitive in terms of the understanding. On the one axis, you've got the number of watts required, but then you've got the cost of the fossil fuel. Just to give you an idea, you've got the green circles that enable you to see the figures for the fossil fuels. Then on the left, you've got the natural gas that amounts to roughly 55 euros in terms of the price. And then you've got the other types of fuel, the propane that is a lot more expensive, around 95 euros per kilowatt hour. And what we see, in fact, is that the fossil fuel is really competitive once you increase its price, hence it's natural gas that is more problematic for the profitability. The difference between wood chips and pellets, well, we see it on the one hand, we can see the right hand cube for the wood chips. This is when you need a lot of heat, when you need a lot of energy in order to provide the heat level that is necessary. Here the requirement is sufficiently high for the pellets not to be competitive. However, for the smaller sized setups, the wood pellets can be extremely competitive, all the more so because the fossil fuel that is used is more expensive. At the end of the day, let me remind you that in the simulation process, we had the top up fossil fuel that is used, larger quantities of used when you use wood chips than when you use the pellets, because the wood chips are not as flexible and not as easily available as the pellets are. So hence this necessity to use a higher quantity of fossil fuel occasionally. So more the requirement in terms of fossil fuels rises when you're using wood chips, the more pellets become competitive in relation to the said wood chips. notably also when you increase the needs, even when the amount of energy required is quite high. So that's what I wanted to say about the dedicated heating systems or units. When it comes to heating networks from a legal perspective, in other words, a heating network that provides heating to several sites, well, in their context, when they use pellets, it's actually quite rare. There are three main situations where they do use pellets. It's when they use pellets instead of coal, when they use pellets instead of wood chips, and when they use pellets because it's the first time around. Now, when they use pellets to replace coal, it's for the big heating units that used to use coal, that had coal-fired boilers in the past, for example, that were pretty powerful. So in that context, the pellets have simply been used to replace these setups, and there's a high heating capacity installed base as well. Then sometimes you have these dedicated boilers with a capacity of over 500 kilowatts, and in that case, the large pellet installations are often used to replace coal. Next, pellets can be used as a top-up, as I've said, in relation to the main energy, and the main energy can be wood chips, for example. This is the case in Montpellier, where they use a lot of wood chips as a basis for their system, and the pellets are simply used as a top-up to replace the coal. So there are two reasons why the pellets have been chosen in this context. It's the fact that the granulometry, the size of the actual pellets, is quite close to what was used in the past for the coal. So this makes it possible to switch to biomass without having to make any further investments on the actual system. And the other aspect is the room available in the city centre. It's not necessarily possible to store a lot of wood chips. The pellets take up less space. It's not possible either necessarily to allow a lorry to get close to the site and to offload the wood chips. This could take up too much space and be too cumbersome in terms of the size of the truck, unlike for the pellet delivery. The same thing is true for the dedicated heating systems. The silo, it all depends on the size of the silo. That is what will dictate the choice. Is it going to be pellets or wood chips? And obviously, as I've said, the pellets take up a lot less space. The second main type corresponds to the pellet boilers that are there to offset or relieve or take over from the wood chip boilers. Often it's because natural gas is not provided. If natural gas was provided, that would be the natural top-up energy rather than the pellets. And in certain areas where there's no natural gas, obviously fuel and propane as top-up heating are quite expensive, and hence the pellets are a lot cheaper. So it's much better to choose the pellets and have 100% renewable energy. There can also be another situation whereby a fully fledged pellet boiler can be installed to provide the energy. Instead of installing a boiler with wood chips, a pellet boiler is installed. And this would seem to be the most interesting from a price perspective, and more often than not, this is what is validated. We have only one case of pellets that have been used as the main system. This was in an eco-friendly neighborhood where a deliberate choice was made. That's what I wanted to say by way of the presentation. I imagine there must be quite a few questions. Yes, a certain number of questions that are piling up. Let me now pass the floor over to you, Stéphane, again, because there's a technical question in relation to television program. There's a journalist who broached the subject yesterday. I'm not going to go into detail on this. Please feel free to read in the chat. Next, the question I have concerns the maintenance costs of a pellet heating unit. I'm told that it's the same cost as for a standard boiler with fossil fuels. So what about the power ratio as well? Can you tell us about the operating cost depending on the size of the pellet boiler in relation to a standard gas or coal-fired boiler? Well, when it comes to a fossil fuel boiler, if we compare the maintenance costs, it is true that generally speaking, for solid fuels, then the operating cost is higher than it is for liquid or gas-based fuels. It so happens, nevertheless, that pellets They're solids, but even so, the characteristics, the inherent characteristics that they have do make them very similar to a fluid, if not liquid product. Their granulometry is small, the pellets are small, so it's a lot easier. I'm looking for the right word here. It's a lot easier to deliver, to transport them. There are a lot fewer issues with pellets than there are, for example, with wood chip boilers. Next, the maintenance cost, it's true, is higher than for fossil fuel furnaces or boilers. Having said that, I'm looking at the question at the same time as you're answering it. I'm not quite sure about the independent cost of the boiler house. I think it varies from one site to the next. It depends on the size of the boiler. It would be of interest to calculate what the price is, but it's true that the maintenance costs can be quite high, but it's on condition that you don't extend beyond a certain production rate and a certain size of the boiler. Obviously, the price will be concomitant with the size of the boiler. If the boiler is small, then the operating costs are likely to be a lot lower and vary quite a lot, but maybe not that much. I can't really say. Okay, I can see that we have a question from another person. What about wood chips made of wood shavings? I'm not familiar with those. So, Stefan, I don't know whether you're familiar, or Mr. de Boulet, if you would like to speak, but I'm not aware of this fuel. It reminds me of what we call the tiny bricks, wood shavings that have been kind of pushed and crushed together. If that's what you're talking about, then I would say they are a lot more similar to small logs. It's as if we're talking about tiny logs. And so in big heating systems, I don't believe it's viable. You just can't imagine having this type of fuel. Okay, so it's the standard kind of wood chip that we use in the house to replace logs. And yes, sometimes they can be made up of pellets, but they're log size. So yeah, it's a form of log. Okay, I hadn't created the link. Are there any questions? We've only got 2 more minutes left if we really want to stick to the timing that has been allocated to us. There's been one question right from the outset. Yes, that's a good idea. Can you answer that question? Because I asked the person to refer to the study itself because I thought the question was very precise. Please, can you communicate figures that will enable us to understand the lack of competitiveness of the pellets in relation to gas? I don't know whether I can say something in 1 or 2 minutes. Well, basically what really makes the difference, what I can use to explain it, is that the difference between the cost of the fuel, pellets and gas is not sufficiently high to offset the excess cost of the investment. In other words, it might be easier to see for wood chips here the difference between wood chips and natural gas. The price is a lot higher, a lot more so than for pellets and gas, but the investment cost is bigger for the wood chips than for pellets. But above and beyond a certain level of power, of heating power, it might be of interest to go for the pellets or the wood chips because the added heat makes it worthwhile. So it basically depends on the gap, the difference between the cost of the actual pellets or the wood chips. The cost isn't sufficient to make it viable to amortize the cost necessarily of the additional investment that is made necessary, unless you need a very big boiler. That's basically what we're saying. Now, I've added the link to the study on the ADEME site, the French Agency for the Environment and Energy Management. Do feel free to consult this. It's a lot more detailed than anything we've been able to go into. So I do invite you to read this document, and feel free to contact Stéphane COUSIN, whose email is on the last slide, or feel free to connect myself if you need any further information, and we'll try and answer your questions. So I think we're pretty much running out of time. Thank you for your messages. Okay, wonderful. Yeah, I think time is marching on and we need to say goodbye. Thank you very much. And I'll let you say goodbye as well, Stefan. Yes, thank you very much, everybody. And thank you to the organisers. Thank you for having given us the opportunity to give this presentation on pellets and wood chips and the question of their competitiveness in comparison with gas. And see you next time round. Bye-bye.